It's a good question. One of those things you wonder about as a kid. You look at a car, then you look at a dog, and you think, why not both? Why didn't nature, in all its wisdom, ever give an animal a set of wheels? We use them for everything. Cars, bikes, office chairs, shopping carts. The wheel is one of the most important inventions in human history. It seems so simple, so efficient. Surely evolution, with its billions of years of trial and error, would have stumbled upon it. A wheeled cheetah on the plains would be unstoppable, right? A wheeled turtle would be, well, a little faster. But you look around, you go to the zoo, you watch a nature documentary, no wheels. Not a single one. You see legs, fins, wings, tails. You see creatures that slither, crawl, hop, run, swim, and fly. But nothing rolls on its own, built-in axles. It seems like a massive oversight. A missed opportunity. The truth is, it's not an oversight. Evolution didn't miss the wheel. The wheel is just a really, really bad idea for a living thing. It's a great idea for a machine, for a non-living object. But for biology, it's a non-starter. There are a few deep fundamental reasons why, and they show you a lot about how evolution actually works versus how we think it should work. The first problem is the biggest one. It's so big, you can almost stop right here. How do you grow a wheel? Think about how your body's built. Everything is connected. Your arm isn't a separate part that was bolted on. It grew with you. It has bones, muscles, nerves, and blood vessels all running through it, connecting it to the rest of your body. Your heart pumps blood down your arm to your fingertips to keep the cells alive. Nerves run down it so you can feel a hot stove or move your fingers. If you get a cut, your body sends resources through those blood vessels to heal it. Everything is integrated. A wheel, by its very definition, has to be separate from the body to work. It needs to spin freely on an axle. Imagine a wheeled deer. Its wheels can't be connected by living tissue to its body. If they were, the blood vessels and nerves would twist up and snap the first time the wheel made a full rotation. It would be a disaster, so the wheel and the axle would have to be dead tissue. Something like fingernails or hair or a rhino's horn. It could be made of keratin or bone. That's possible. Nature makes dead, hard structures all the time. But how does the body support it? The axle has to pass through the body. This creates a seal, a permanent hole in the animal's side. This is a huge invitation for infection. It's a weak point. And how does the wheel grow? Does it grow in place? If it does, it's attached and it can't spin. Does the animal grow it somewhere else on its body and then attach it? How? Animals don't assemble themselves like a model kit. They grow in one continuous connected process. Maybe the animal could shed its wheels and grow new ones like a deer sheds its antlers. That seems incredibly inefficient. Imagine a gazelle being chased by a lion and suddenly one of its wheels falls off. Or it gets a flat, what does it do? It can't patch the tire. The wheel is dead tissue. It can't heal itself. Any damage is permanent until it can be replaced. A leg can heal. A broken bone can mend. A sprained ankle can recover. A wheel is a disposable part, and nature doesn't really like disposable parts for critical functions like moving. The single problem, the problem of creating a freely rotating separate part that is still part of a living, growing organism, is probably the main reason the biological wheel never happened. Biology is all about connection. Wheels are all about separation. The two concepts just don't mix. But let's say for a moment that nature solved it. Let's imagine a magical process where an animal is born with 4 perfect hardened wheels on smooth dead tissue axles. The biological miracle is done. Now you have the second problem. How do you power it? Your leg moves because muscles pull on your bones. Muscles are simple things. They can only do one thing contract. They pull, they can't push, they can't spin. Your bicep contracts. It pulls on your forearm and your arm bends. Another muscle, the triceps, contracts to pull it straight again. It's a system of levers. How would a muscle power a wheel? You can't just attach a muscle to the top of a wheel and have it pull. That would just make the wheel wiggle back and forth. To get continuous rotation, you need something more complex. You need to turn that back and forth pulling motion into a circular spinning motion. In human machines, we do this with a crankshaft. A piston moves up and down, pushing a rod that turns a shaft. It's how a car engine works. Could an animal evolve a biological crankshaft? The system of bones and ligaments that work like a piston and a rod? Maybe. It would be incredibly complex. You'd need multiple muscles firing in a perfect sequence to keep the motion smooth. Compare that to a leg. A leg is simple. A few muscles, a few bones acting as levers. It's direct. It's efficient. Evolution is a tinkerer. It works with what it has. It doesn't design a complex engine from scratch. It modifies a fin into a stubby leg, then a longer leg. It modifies a jawbone into an ear bone. It takes the simplest path. Building a biological rotary motor is not the simplest path. It's probably one of the most complex paths imaginable. Think about the control it would take. When you walk, your brain is making constant tiny adjustments. You shift your weight, you flex your ankle, you bend your knee. It's an active, dynamic process. A wheeled system would be just as complex to control. You need a way to brake. You need a way to deliver different amounts of power to different wheels to steer. It's another layer of engineering that nature would have to invent from scratch. So you have the impossible biology of growing it and the nightmare engineering of powering it. Even if you solve both of those, you run into the third and maybe most practical problem. Where would you even use wheels? Wheels are fantastic on roads, on floors. On smooth, hard, flat surfaces. The world we live in is a world we built for wheels. We flattened mountains, paved over forests, and laid down millions of miles of asphalt. The natural world is not like that. The natural world is a mess. It's full of hills, rocks, mud, sand, rivers, fallen trees, and bushes. A wheeled animal would be a joke in most environments. Imagine a wheeled deer trying to run through a forest. It would get stuck on the first route. Imagine a wheeled pig trying to navigate a muddy field. Its wheels would just spin and sink. Imagine a wheeled mountain goat. It's ridiculous. Legs are amazing. A leg can step over a log. It can find a foothold on a rocky slope. It can push through mud. It can wade into water. It can jump a ditch. A leg offers discrete points of contact with the ground. A wheel needs continuous contact. The moment that contact is broken by an obstacle or the ground gets too soft, the wheel fails. Legs are all-terrain vehicles, wheels are for the highway, and nature doesn't build highways. You could argue that a wheeled animal might evolve on a vast flat plain like the African savanna. That's probably the best case scenario, but even the savanna isn't a parking lot. It has termite mounds, riverbeds, seasonal mud, and patches of thick grass. A running antelope on 4 legs is far more agile and adaptable than any wheeled creature could ever be. It can turn on a dime, it can leap. A wheeled animal would have a massive turning radius. It would be fast in a straight line on perfect ground and helpless everywhere else. And how would it get up if it fell over? Most 4-legged animals can use their legs to push themselves back up. A wheeled creature lying on its side would be like a flipped-over turtle. It might be completely helpless. Predators would figure this out pretty quickly. Just tip it over. This environmental problem gets to the heart of how evolution works. Evolution doesn't have a goal. It's not trying to create the fastest animal. It's creating animals that are good enough to survive and reproduce in their specific environment. And in virtually every natural environment on Earth, legs are a better, more versatile, more reliable solution than wheels. The payoff for developing a wheel just isn't there, because the world isn't built for it. This leads to the 4th point, which is about the process of evolution itself. Evolution builds on what came before. It's a process of small, gradual changes. A fin slowly becomes more robust, more able to support weight on land. A scale slowly becomes a feather. A leg slowly becomes a wing. There is a path of tiny, incremental steps, where every single step is a slight improvement, or at least not a disadvantage. The famous scientist Richard Dawkins used the metaphor of climbing Mount Improbable. You can't just leap to the top of a sheer cliff, but you can walk up the long, gentle slope on the other side. Evolution always takes the gentle slope. The wheel has no gentle slope. It's a sheer cliff. What is half a wheel? It's not a wheel, it's just a lump. What is a leg that is partly detached so it can spin a little? That's a broken leg. It's a disadvantage. An animal with a proto-wheel would be less fit than its cousins with normal legs. It would be slower, clumsier, and more likely to get eaten. Natural selection would weed it out immediately. For a wheel and axle to be useful, they have to appear at the same time, fully formed. Having a wheel without an axle is useless. An axle without a wheel is useless. You need the whole system at once. Evolution doesn't work that way. It can't make big, coordinated leaps in design. It can't aim for a future goal and say, okay, for the next 2 million years, we are going to work on this wheel and axle project. It will be terrible for a while, but trust me, it will be worth it in the end. There is no in the end. There is only now. Does this trait help me survive and make babies right now? And a half-evolved wheel does not. So we have 4 huge barriers. The biological barrier, you can't grow an integrated living wheel. The engineering barrier, it's incredibly hard to power a wheel with muscles. The environmental barrier, the natural world is a terrible place for wheels. And the evolutionary barrier, there's no gradual path to get there. Now, you might be thinking, but are there any exceptions? Did nature ever get close? And the answer is yes, sort of. It's fascinating. There are animals that use rolling as a form of movement. The cartwheeling spider, found in the deserts of Morocco, will do a series of rapid handsprings to escape a threat. It can move much faster this way on the sand than it can by running. Pangolins, when threatened, will roll up into a tight armored ball. If they're on a hill, they can just let go and roll away. Some caterpillars will curl into a circle and roll away from danger. But notice the difference. In all these cases, the animal is rolling its entire body. It isn't using a separate rotating appendage. It's a temporary escape maneuver, not its primary mode of transportation. It's a clever trick, but it's not a wheel. It's the difference between rolling a log down a hill and putting wheels on the log so you can drive it. The most famous and incredible exception, however, is found in the microscopic world. There is one place in nature where a true freely rotating wheel and axle motor exists. It's the bacterial flagellum. Many bacteria have a long whip-like tail called a flagellum that they use to swim around. For a long time, scientists thought it just wiggled back and forth like a tadpole's tail. But then they discovered the truth. The flagellum spins. It spins like a propeller. At its base, where it attaches to the bacteria's cell wall, there's a tiny, complex molecular motor. It's made of proteins. There's a rotor, a stator, a drive shaft, and a bushing. These are all engineering terms because it's a true machine. It runs on a flow of protons instead of gasoline, and it can spin at over 100,000 revolutions per minute. So, there it is. Evolution did invent the wheel, but it did it at a scale so small we can't see it for a purpose propulsion in water disappeared that is very different from moving over land. Why could it happen here, but not in a big animal? The scale changes everything. At the molecular level, the growing it problem is different. The motor isn't grown like a limb. It's assembled from individual protein molecules. The cell makes the parts and puts them together. There are no blood vessels or nerves to worry about. The powering it problem is solved by using chemical energy, the flow of ions, not the contraction of muscles. And the environment problem is different. The physics of moving through water at that tiny scale are dominated by viscosity, not by bumps and obstacles. A propeller is a great solution in that world. The bacterial flagellum is the exception that proves the rule. It shows that under a very specific and alien set of circumstances, a biological wheel is possible. But it also highlights why it's impossible for large, tissue-based animals. The problems of construction, power, and terrain are just totally different. The flagellum is an amazing piece of natural engineering, but it's not a blueprint for a wheeled lion. So, in the end, the reason we don't see animals with wheels is not because evolution lacked imagination. It's because evolution is practical. It's a pragmatist. It works with what's available to solve the problems at hand. And for the problem of getting a body from point A to point B in the messy, complicated, beautiful natural world, legs are just a better, simpler, more robust, and more versatile solution. They always have been. The wheel remained undiscovered, not because it was a bad idea, but because it was a human idea. It's a solution that only really works in a world that has been reshaped by humans. We didn't evolve wheels, we invented them. And with them we flattened the world to suit our invention. That's the real story. The wheel isn't a feature of the natural world. It's a tool we created to tame it. We look at a car and a dog and see two different solutions to the same problem of movement. But nature and humanity were solving two different problems all along. Nature was solving for survival in a complex world. We were solving for efficiency in a simple one of our own making. And for that, we needed to invent the wheel ourselves.